Hello, everyone. Wanted to make a quick video for you to help you with um, kind of an oddball question in section 5.3. So I know section 5.3 homework was due last night at midnight, but I want to kind of rock through this because I've gotten a lot of questions about this one today. And I know I didn't specifically prepare you for this one, but there was a hint on this. And I'm not going to test you on this. But the reason this problem is in here is because it's going to prepare you for kind of how to do a couple of processes in Calc 2. So I wanted to just kind of make sure that we understood how to do this so that once you get to those processes in Calc 2, you have a better understanding of how to do these. Okay, so I need to find a C1 and a C2 such that big F of x equals C1 times F of e to the negative x plus C2 times e to the negative x is an antiderivative of little f. So big F is an antiderivative of little f. That means the derivative of big F is the same as little f, right? That's what it means to be an antiderivative. So I'm going to take the derivative of big F, and then that should be the same as little f. So that's how we're going to find C1 and C2, right? The derivative of your antiderivative is little f. Okay, so first I have to find f prime of x, which means I'm taking the derivative of this guy. Now notice, to take the derivative, I need a little product rule here. So when I take the product rule, I'm going to do the derivative of the first, which is just C1, times the second as is, which is e to the negative x, plus the first as is, C1 times x, times the derivative of the second, which the derivative of e to the stuff is e to the stuff, times the derivative of my stuff. And then, so that's the derivative of this first piece, and then I have to add to that the derivative of the second piece. The derivative of a number times e to the negative x is that number times e to the negative x times the derivative of negative x, which is negative 1. Okay, so I'm going to make this look a little nicer. So I've got c1 times e to the negative x minus c1x times e to the negative x minus c2 times e to the negative x. Notice these two are like terms. So I'm going to write them kind of next to each other here. And when I write them, I'm going to factor out an e to the x on this. So I'm going to have c1 minus c2 times e to the negative x. That's how I'm going to write these because they're like terms. So like if I had 3 e to the x minus 2 e to the x, I would subtract that 3 minus 2. That's how many e to the x's I would have. So that's how I'm going to write this. All right, so that's my f prime. And I know that this f prime has to be equal to little f in order for it to be an antiderivative. So I know that this thing, my f prime, has to be the same as little f. So I know that 9 times x times e to the negative x has to be equal to negative c1 x e to the negative x plus c1 minus c2 times e to the negative x. Okay, so I know that this has to be true because I want this to be equal to the antiderivative, or the derivative of the antiderivative. All right, so notice, in order for these two things to be equal, I have an x times an e to the negative x, which means that I know that 9 is my negative c1, right? Because this is my x e to the x, and it has to be the same as this. We're basically comparing pieces of this. So I know that 9 has to be equal to negative c1. So that tells me that c1 is negative 9. But then how do I get to c2? Well, in order for this to be the entire derivative and be equal to this, not only do I need this c1 to be 9, so that I have a 9x e to the negative x, but notice I also don't have any e to the negative x's here. So I can think about having 0 e to the negative x's over here, which means in order for these two to be the same, I also need c1 minus c2 to be equal to 0. I can't have any just e to the negative x's because I only have x e to the negative x's in my little f. So I need C1 minus C2 to be 0 so that I don't have any e to the minus x's in there, which means C1 is equal to C2 if I move that C2 over, and that means that C2 is also negative 9. So I have just found both C1 and C2. But the process that's really going to help you in Calc 1 is this idea of comparing what we have to what we need it to look like. And if you're missing pieces, understanding that the coefficient of that missing piece has to be 0 in order for these two things to be equal. This is a process that you're going to do a couple of different times over in Calc 2, and I think that'll help you with it. So I hope this is helpful. And it helps you complete your 5-3 homework, and it gives you a little bit of a boost to understanding Calc 2. I will see you next time. I hope you have a lovely day.